It's good to be with you. Welcome to Class Outside. Today, we are going to learn how to export a path from Blender and use it in ThreeJS. For this project, we will need Blender installed. This is where we will create the Nurbs path. NURBS, or Nurbs, stands for Non-Uniform Rational Basis Spline. A Nurbs path basically describes a line and a bunch of points that pull the line in many directions. This leads to a smooth, curved line. In this demonstration, we will use a few 3D models to set up the scene. Each are currently freely available on the website Sketchfab. Links to these 3D models can be found in the description. Down there, you can also find links to GitHub repositories and other descriptive tutorials mentioned in this video. We will need the Nurbs for ThreeJS Blender add-on. This is available for free on GitHub. We need a tool to edit code. I will be using Visual Studio Code. We will need a project using ThreeJS to import our Nurbs path to. This project is also available for free on GitHub. The necessary steps to run this project are provided in this video. For more detailed information on the tools used in this project, links to some descriptive videos are provided below. Finally, we need a package manager like Node Package Manager or NPM to install the dependencies for the project. To start, we must set up our scene in Blender. For this scene, the edited maze model was placed on a table in the room. A camera was added to frame the view, as well as some lights. Export the scene as a .glb. When exporting, include the lights and camera. Before using your scene in a ThreeJS project, the free website 3js.org/editor may be useful. Models displayed when using ThreeJS may look different than in Blender. This website allows you to make adjustments before using the final scene. A video with more details on exporting Blender scenes and importing them into ThreeJS can be found below. Next, we can create our Nurbs path. The Nurbs path will be demonstrated as a line going through the maze. In Blender, press Shift-A, go to Curves, then select Path. This process should also work if you choose Curve. Go into Edit mode. Now, move the path so that one vertex is at the start of the maze. Select the final vertex and press E for Extrude. This will make another connected vertex. When you move this connected vertex, it will extend and affect the line as a whole. Use left-click to place the new vertex. Continue this process until the line exits the maze. ThreeJS currently cannot import curve or path data from Blender. To translate our path into something ThreeJS can use, we'll take a few steps. A copy of the curve or path will be converted to a mesh. This mesh will have only vertices and edges. Since ThreeJS also cannot import meshes that are only vertices and edges, we need to save this data to a file that ThreeJS can read. That type of file is called a JSON. JSON stands for JavaScript Object Notation. JSON files are a standard way to share data about things. In this case, we will share the position of each vertex in the mesh. To put this information into a JSON, we can use a Blender add-on. Blender add-ons provide extra features to Blender. ThreeJS can read the JSON and create a new curve from it. This won't be called a Nurbs curve or a Nurbs path. In ThreeJS, the nearest equivalent to a Nurbs curve or path is called a Catmull ROM curve 3. Let's start the work by making a copy of the Nurbs path. With the copied path selected, right-click in the viewport, go to Convert to, and select Mesh. Next, we need to click Object, Apply, and then All Transforms. If you do not do this, the vertices may appear in the wrong positions when loaded in ThreeJS. Now that the Nurbs path is prepared, a Blender add-on is required to export the curve to a JSON file. The code for this add-on is available for free on GitHub, linked below. Click the Code button, then download the zip file, and then extract it. Open Blender again, go to the Edit menu and select Preferences. Click the Install button. Navigate to the directory the extracted add-on is in. Select it. Make sure the add-on named Export Vertices to JSON has a checkbox in it. Select the mesh representing the Nurbs path. Click File, Export, and you should see a new button named Export Vertices to JSON. Choose a folder to save your file to, name it, and make sure the name ends with .json. Back on GitHub, download the Blender Path to ThreeJS project. For the scene and the curve to be accessible by the code, they must both be placed in the dist src models folder of the project. Copy these here now. Open this code in your preferred editor. Open a terminal window, then navigate to the folder containing the package.json file. Using a package manager, install the project's dependencies. I'll do this with npm install. In the file titled mainView.js, make sure the scene path and curve path have names that match the scene in JSON you pasted. Let's review the code that adds this curve to the scene. We see that the load curve from JSON is a function called with the path to the JSON we created. Load curve from JSON comes from the curvemethods.js file. This loads the JSON information into a variable called curve.json. Then, that information is used in the createCurveFromJSON method. To understand what this is doing, it can be helpful to know what the JSON looks like. In a JSON, curly brackets describe an object, and objects can contain other values and more objects inside of them. The file we exported has two values in it. These values are points and closed. Points has a square bracket, which means it contains an array of multiple values. There are many objects in points, and each contain the position for one vertex in the Nurbs mesh from Blender. CreateCurveFromJSON goes through each of these points and uses them to create a list that represents all vertices in the curve. This list is then used to create the ThreeJS equivalent of a Nurbs curve or path, called a catmull rom curve 3. The closed value is an optional feature that can be used if your path is closed in a loop. This can also be edited in the JavaScript side. The getToFromCurve function is also called. This is an optional method to visualize the curve. It takes the curve data and makes a mesh around it. LoadCurveFromJSON returns the curve and the mesh associated with it. Back in the mainView.js, we see the mesh from this returned object is used and added to the scene. This is all the code required to create a curve in ThreeJS from the JSON file. Let's run the program and see if the curve appears. In the terminal window, type npm run start-dev. Two command prompts will appear. This is a JavaScript bundler called Webpack. It makes the final code more compact. Another video where you may learn more about Webpack is linked below. Let's open the web browser and go to localhost:3000, or any alternate port you may have configured. Look at that! Together we have taken a curve from Blender and imported it in ThreeJS. Please, let me know down in the comments what you've thought of this video. Have a great day, and thank you for attending Class Outside.